first, I think we need some language to talk about chromatography. So we can talk about the volume flow rate, which is in milliliters per minute, usually. Milliliters of solvent going into the column per minute. You can have a linear flow rate where you have the solvent, the rate at which, in centimeters, at which the solvent moves through the column. And so that's in centimeters per minute. You can also have T sub r, which is retention time, the time that you need to, the time that elapses from the start when you eject your sample into the column to when it comes out for each component. You can also have retention volume, the volume of solvent that's required to flush a specific solute through the column. You can also talk about adjusted retention time, where it's T sub r prime, and that's the time that it takes to get your particular solute out, minus the time that it takes to get the solvent, to have the solvent first come through, because because of the interaction, the interaction with the solid phase or with the stationary phase, what you're trying to get out of the column won't come out as soon as the solvent comes out, which doesn't interact with the stationary phase. You can also talk about relative retention or separation factor, and that's alpha equals the relative retention of one component versus another component. It's always greater than 1, so however you arrange your numbers, it should be greater than 1. And basically, this is something that you would use to, like an internal standard. If you knew that your mixture that you were trying to separate had methanol in it, but you were looking for something else, then you might use methanol to say, okay, so the methanol came out here, and then this other thing is probably going to come out at this other time. And so it's a way of sort of standardizing for slight differences in flow rate or gas flow rate or solvent flow rate through your column. So we talked about that a little bit in the first, long time ago, in the first probably month of the semester. So just a couple more things real quick. We can also have something called the retention factor K, where you have basically T sub r prime, or TR minus TM, divided by the time that so this is divided by TM, so this how it moves through the solvent. So this is basically the time that the solvent spends in the stationary phase relative to the amount of time it spends in the solvent phase, or spends traveling with the solvent. So you can also write this as the concentration as concentration times volume. So basically moles of solute that's in the stationary phase versus the moles that are in the mobile phase. So that's the concentration times the volume. And you can work this out so that basically these two concentrations are essentially the partitioning coefficient that we talked about earlier as far as the solvent extraction times the volume ratios, which is also equal to T sub r prime divided by Tm. So these are just a couple things that we can use to talk about chromatography, and we're going to be using these definitions and these tools when we sort of dive in deeper to try to talk about retention or peak resolution and column efficiency and those types of things, which is what we're going to talk about now.